Hi everyone! Welcome back to another week of Heuristics Science Facebook Live. I'm Ms Sayuri and I will be your host for tonight. Okay, great. We are still in the midst of our higher order thinking intensive revision. Okay, so we have been, of course we cannot cover everything, but we have been showing you examples from every single theme of topic. So far we have already done diversity, system, and one more. Uh, cycles, right? Okay, and so today we're actually going to do interaction, which is, well, mostly a primary six topic. Okay, the only time you actually touch on interaction before that is during primary three, kind of touch and go on methods. Okay, so interaction we're talking about man's impact. Okay, we're talking about food chain, food web, forces, and also adaptation. So now today was going to be a quick one. Okay, I just wanted to touch and go some of the interesting questions that I came across. Okay, so without further ado, if you're in the house, can you just say hello to me so that I know that you're in here? And if you don't have today's worksheet, you can always download it in our Telegram group. Okay, great. So let's actually get into it. So I know that today's thumbnail was like a butterfly right next to my face. So why don't we talk about that? Over here, right? The reason why we chose this butterfly is because I just find it really, really amazing. Okay, so this is actually a normal butterfly, right? Okay, so usually it looks like this, but this particular butterfly, when it opens up, right, it looks like, what does it look like? It looks like the eyes of an owl, right? So it appears way bigger than it is. And the craziest part is if you fold the wings in a certain way, the same butterfly over here now looks like the head of the snake. Okay, so owls and snake both are actually predators of small birds, and these birds actually are the predators of this butterfly over here. So, it's really crazy how nature is, because they can actually appear a lot bigger and even appear to be the predator of their predator just to fool them. Okay, so I didn't prepare a question for this, but I thought maybe we should just share a question on that. Can I not? Okay, so let's actually talk about these questions today. Okay, so I only prepared two questions, but it is very, very interesting. Okay, sometimes, right, the question doesn't really fall into like a topic directly. It touch and goes some topic, but it's not quite there. So this is an example of a really very weird question, right? Because you will notice that they didn't really talk about gravitational force, not really. Okay, they didn't even ask about like energy conversion. Okay, so let's read this question now. Sharon prepared the following setup using the blocks W, X, Y, Z, and they are all different mass, different size. Okay, so in this case here, right, you can see that all three of this W, X, Y is the same mass. Okay, and the areas in contact with the sand is different. So over here we're talking about, you see, right, maybe if they block it this way, this here would be considered 100 cm square over here. This is the part that is in contact with the sand. Okay, so 50, and the last one they did say is 25. Okay, so you can also like draw that back in. Of course, if you really want to draw a 3D model, you can join it to the end also. So this would be a 3D model of a cuboid. So here. Okay, so we're only focusing on the surface area. So this is the surface area that first touched the sand. Okay, and we know that Y and Z are the same surface area. Okay, so over here, right, it says that based on the above results for the block of based on the above results, okay, for the blocks of the same mass, what is the relationship? So same mass, right, you don't look at Z, Because same mass, right, we can only compare W, X, and Y. Can you see that? And they're asking you for the relationship between the area of area of contact with the sand. The English is phrased in an interesting way. Okay, so area of contact with the sand, okay, against the depth of depression. Now, this depression is not, I'm so sad, not that depression. Depression is when you press in, how deep does it go? So, if you were to drop it at the same height every time, over here, this H, right, is going to be your constant variable. Can you see that? Okay, and you're going to measure the depression of the sand, which is measured variable, and it looks like you also keep the mass the same, up to Y anyway. And you look at, you are changing the area of contact, so therefore it looks like as the, you could look from here or here. So I actually already prepared your sentence. A lot of students had to still write the more the area, the deeper the sand. If you write like this, right, it's straight zero, okay, I tell you first. Because the area of what, right? And the deeper the depth and stuff like that doesn't cut it. What you want to do is to always mention exactly mention exactly the change variable and the measured variable. Can you see that? Okay, so how do you know for sure? It's always likely in the question. The area of contact with the sand against the depth of depression form. Okay, so over here I printed, as if you print a paper, you already have this. So if it increases, so I'm looking at it this way. So from 25 to 100, okay, what happens to the depth of depression? Can you all type down in the chat? Okay, I see. Yes. Okay, so some say increase, some say decrease. So actually, which one is it? Okay, so let's actually take a look. So I'm going to be arrowing down to this. You can also write it in as the area of contact with the sand increases. Okay, then over here, the depth of depression form, you're gonna go to this box here. From 25 to 100, it goes down from 8 to 3 cm. That's insane. Okay, for the same mass even. So it is actually an up-down relationship, as I call it. Okay, so as something increase, the other one decrease. But teacher, can I write decrease then increase? Yes, can. Okay, as long as you tell me an inverse relationship. Can or not? Okay, so now next one. Oh, you should receive a different one. I already swapped this TCR, so give a moment. So it's actually like this. Okay, so over here, large animals found in the desert may sink into the sand easily. Oh, okay, so that's pretty random, don't you think? At first, we were just showing you some blocks and some sand. Okay, and then after that, suddenly in the next part, right? This should be part B. Based on the result from Sharon's experiment, why does having large flat feet explain why having large flat feet is an advantage for animal P? Okay, so you know that your camel here, which is animal P, is going to be heavier than 300 gram, right? But following this logic here, if you were to, have you ever tried? Maybe some of you, maybe ladies or maybe your moms, if they are wearing high heel, they will not step on the sandy beach. Okay, because why? The heels will sink all the way in, right? Preferably you want a nice flat slippers to step on the sand so that your feet do not sink all the way into the sand. Okay, so now our feet is pretty wide, but the camel's feet even wider. Okay, as compared to maybe there are similar cousins like horses, donkey. Actually, your camel would have way bigger feet. Right? Actually, don't take it from me. Let's actually take a look at some pictures of camel feet. Okay, you see that? It is actually way wider. You see that? And it can still stretch out. Yeah. Okay, and you just compare that to hooves of a horse. They're very, very different. Can you see that? So if you bring a horse to the sand, they are not as well adapted to walk in the sand compared to a camel like this. Okay, so now in this case here, right, based on Sharon's experiment, so having large flat feet advantage to P. So right over here, this is actually, you know what, in the end, right, is an adaptation topic, you know. Okay, so when I saw this question at first, it actually threw me off. I said, I thought you were asking about energy conversion. I thought you were talking about gravitational potential energy, maybe. But it's not. Turns out, there you go. I mean, I can ask a gravitational potential energy question, converted kinetic energy, and that is seen further, sure. But that's not the question they're asking. Over here, they're actually asking about camels. Okay, so this is why we chose such questions, because right, a lot of the questions in your PSLE, right, the first part of the paper is talking about experiment based question, and then the second part of the paper, right, is talking about real life scenario, okay, which is maybe completely you won't think of until you see the question. But what's more important, right, is to base the results or base your explanation on the experiment. That is more important than trying to craft out a new answer yourself. Remember, right, if it's still the part of the same question, it must be related somehow. Okay, so in exam, you got stuck, right? They say, oh, randomly give me a camel. Go to the previous page. Think harder. Cannot think about what kind of link with flat feet versus the area of contact with the sand. Okay, great. So now in this case here, I'm going to put this as the clue. Okay, and I mean, this is one clue over here, and the other one, I'm going to give it to large flat feet. Clue number 2. Okay, so actually they already given you the advantage, but I will expand I'll expand it further later on. So this one over here does not have any difficulty walking. Now, the danger is students just write, oh, because it's a flat feet, so you won't sing, so if you won't sing, then it's not difficult to walk. Like this, right, you are not answering the science of it. Okay, no, if they already write it here, right, it cannot be part of your answer. Can you see that? So you see, right, advantage here, you need to explain. You need to tell me the science behind it. Okay, so because it's an adaptation question, those of you who are our students, you will know, we actually adopt the TCR answering technique. Yes, but we tweak it a little bit. Clue becomes the feature. The concept becomes the function of the adaptation. And the result now is talking about the factor of adaptation. Okay, so over here, I will just pen this down. Okay, we have a few things here. Large flat feet. Okay, so those of you who have the paper, you can also write it down together. And then you have this relationship over here, right? So you'll know that if you have large flat feet, you actually increases the area of contact with the sand, okay, which is going to in turn lead to decreasing the depth of depression formed on the sand. Okay, so in that case here, in the end, you already have the end result. You just not have difficulty walking in the sand. So I'm going to just write down here. on sand more easily. Okay, so you realize that my answer is also in level 2. So this is like a good thing. It is better for the camel to have large flat feet. Okay, because if you don't want to write increase the area of contact, you can also write area of contact with the sand is larger, depth of depression is greater. Then after that, you can also say that you can walk on sand more easily or easier, up to you. Okay, so in this case here, you left your factor, you cannot end your answer here. What else should you be writing? Anybody? Okay, so this tested focus is actually a structural adaptation. Actually, I should have, yeah, I actually wanted to put it here. Oops. Okay, so if you can just shift it up. So this one over here having large flat feet. Over here, this is the, again, feature. Okay, and this is from the experiment, right? But I have no space right here, so I just continue on. And this one over here is the function. And now, students, why do you think they must walk on sand more easily? Why not just walk on sand slower or something? So there must be a reason for adaptation. The reason why camels of one generation after one generation grow slightly larger and larger, flatter and flatter feet. There must be a reason. So this reason over here is considered your factor, and it's something that you must answer during your adaptation question. Like, what is the whole purpose of having this? Yeah, okay, they may be able to have large flat feet to walk on sand easily, but what is the main reason? Why must they do that? Why not just have small arch feet? Okay, so in this case here, what are we trying to do? We are trying to increase. We are trying to walk faster. If you can walk easily, you can walk faster to find things like food or water. Now, you can also say, escape from predator more easily. But I checked it already. Actually, camels have very, very little natural predator. They don't, because they're so big, right? Okay, so if you have, but they don't need you to know this. So if you have written to escape from predators more easily, go ahead. Okay, why not? So in this case here, if you can walk faster to find food and water, you're not like dragging your feet through the sand and tiring yourself out, then in the end, it's all about survival. Increases the chance of survival. Can you see that? So you still need to tell me about the Sharon's experiment. Okay, so if you find that this sentence here is a bit random, you can always say the desert sand so that you can link up with the experiment and the camel. Right, so this TCR template is really here for you to plan your answer. So if you want to tweak like, oh, hey, I write this first, then I write this how, it's fine because you already have the framework for it. Okay, I just don't want students to write because of large flat feet, they don't have difficulty walking, therefore P is a good thing for P. Like this, right, you are jumping from the clue straight away to the result and you are not answering the question. So the answer, right, if you suspect your written answer is way too simple, it probably is. Okay, because no point I test you, I give you 2 marks, and just for you to just copy the text in the question. There must be a little bit more than that. And here is the 2-part answer. One is to link up from the experiment. Second is to answer what does the flat feed do, and why is it good for the animal pee. Can you see that? So this is about food and water. And if you are thinking of escaping from other predators, then the factor would be the presence of other organisms. Okay, there are 7, remember? Temperature, light, food, water, reproduction, presence of other other organisms, and so on. Okay, so this is still part of your living together topic. Adaptation is a big part of it, but it all goes back to the umbrella of living together. Okay, great. So now over here, I have one more question to go. Okay, so no. So over here, right, you can actually piece it back together. It will be exactly the same. You will actually tell me what the large flat feet do and so on. So you end with increase the survival of the camel of animal P. So this is 1, 2, 3. Okay. All right. So now a quick announcement since all of you are here. So as you can already hear, right, the upcoming workshop for primary 6 is on National Day holiday. Okay, it is a fully online class for these two. So if you can't make it, there is still recording for you, but try to make it in person. Okay, so over here, right, I would say that this one is one of the most important workshops that your child can attend with us as a primary 6, because right, it's going to be an entire stack of paper. Okay, I don't need to tell my student to dial it down a little bit. Hold on. I don't want you to be talking at your speaking. It needs to be restored because I'm doing something. I'm still in the Okay, right. Thank you for waiting. Okay, so what's happening here is that we are having a real life experiment, not real life experiment, real life scenario workshop. Okay, so it is really all about the intensive higher order thinking question. Okay, so today is just like a quick preview. The actual workshop is 5 hours. It's on Zoom. It's so long, but it is very, very essential. And if you really need to, you can always request for the recording. But do come, because we have compiled all of the higher order thinking real life scenario question, like what you can see here. Randomly you get a camel, randomly you get a floating cake. That kind of question is the kind of question that PSLE love to test. It's really to throw a curveball at students to kind of scare them with something they have never seen before. Okay, so this one is the workshop to attend. Okay, you can attend it just one workshop, but we are having a early bird promo. Okay, now if you have already signed up for the trilogy earlier, that's the best price already. Okay, so that's like super early bird. But over here, if you are still thinking whether or not to join us for 2 and 3, I would say yes, because for what's that called? For chapter 2, we are doing the real life scenario questions, right? The weird questions, the last 10% of the paper. Okay, that will actually determine whether your child gets AL1 or AL2, AL1, AL2, or it drops, because that last 10 marks is quite crucial, right? And then and also the last sprint workshop, what are we doing? We're doing trends. So that means we are thinking of like the kind of questions that always come out in exams. Then your child must know, right? Because in PSLE year on year, right, the question is like same but different, right? You know that those are the questions that are so standard that your child must know, and that they will most likely see in their paper. If it's not this year, then it's the year after. So we actually arrange our workshops in differently, right? So this workshop is about real life scenario questions. Then the next workshop is about trending questions. Both are important to me. But I would say do come for the 10 August one. In our Facebook Live, it's just not enough time to showcase all the questions. Okay. I just clapped because actually a mosquito has been flying around me for a while already. And I've been I've been bitten. So sad. Yes, okay, so but I didn't catch the mosquito. Alright, so yes. Okay, so now one last question before we end today's live stream. Currently, okay, I have presented this question. Now, this can be a Primary 3 question. It can also be a Primary 6 question. Why? Because in Primary 6, you learn forces. And you don't just learn magnetic force, right? You learn it as magnetic force of attraction, magnetic force of repulsion, and also, what else? You cannot just, magnetic force that of repulsion especially doesn't happen in isolation. It always happens together with, together with okay, yes. Together with gravitational force, yes. Which means that your answer, right, you need to upgrade it to a P6 answer, which is also the reason why I chose this question. Because a lot of students still write it in the P3 way. Your P6 ready, you learn forces, so sorry. The P3 explanation is outdated. You have to write it in the P6 way. Can or not? Okay, so currently I think everybody know object C. The fact that over here is like just a normal cake, and then after that this last portion here is levitating. Levitating means to float, right? Means that object C itself, yes, is a magnet. Okay, so in this case here, based on your answer in A, what have you learned? Based on what you have learned about forces, please explain why the top tier levitate above the rest of the cake. Okay, so now in Primary 3, you learn that light poles facing each other will repel, correct? So now you change. You say that light poles, I'm going to write it here instead because I don't want to keep scrolling up and down, okay? So over here, light poles of magnet in object C and the magnet in the second tier are they are facing each other, yes. Okay, so this part is still the same as Primary 3, right? Now, here's the upgrade. Instead of saying and then they repel, no. You will say exerting a magnetic force of repulsion to do what? So to do what? This time object C is levitating. So you want to say to push object C upwards. Okay, so now if you write this, right, this cannot be a full answer because why is it floating? Why not come down, right? So the reason why it didn't come down, okay, even though we are on Earth and everyone is subjected to gravitational force, is because you know that currently your MFR is greater than your GF, gravitational force. So you have to write a sentence on that, even though it was a little bit awkward, right? But you still need to write it in. Okay, so in this case here, light poles of magnet in C and magnet in second tier facing each other, exerting a magnetic force of repulsion to push C upwards. Okay, so as the magnetic force of repulsion is greater than, now you talk about gravitational force already. The gravitational force exerted, still exerted, use that word, on the object C. I'm just going to write C, okay? Fine, I'll just write object C. Pulling. No. Exerted to on C to pull. Okay, I just write to pull object C downwards. Okay, so what happens in the end? C is, you go back to the end result. The end result says top tier levitate to the cake, then you just follow. Okay, so top tier. Actually, over here, maybe you can write top tier instead. Hold on, let me think. Yeah, let's just do top tier. Okay, because it is not about the magnet anymore, it's about the entire top tier, including the magnet that's hiding inside the top tier. Above the rest of the cake. Okay, so yes. Now can you write, you want to write float, you want to write levitate? I would say just follow their words. Okay, so in the end, right, your answer becomes a 2-mark question. Can you see that? So what's different? after this part, right, is completely a primary 6 answer. Exerting a magnetic force of repulsion, push C upwards. Remember, repulsion is a push force. And then after that, it is greater than the pull force, which is gravitational force. So in the end, it stays afloat. Ta-da! Okay, Ken? Alright, so I will be ending the live stream here. So it's like, if you are not primary 6 and you're looking at this, you will be learning something new today. And if I am talking to any P3 to P5s over here, don't forget that our 10 August is also a very, very exciting day for you. Okay, while the P6 are mugging away with their whole stick stack of real life scenario questions, okay, that are like higher order thinking. A bit difficult, but better with us than at PSLE. Okay, we are actually planning Heuristic Science Fiesta. It's an event. So the Heuristic Science Fiesta has like a 3-part program. So in the morning we are doing experiments workshop. So it's very, very fun. So and then in the afternoon we're actually hopping on a school bus. We are bringing you to Santopia, right, to learn about how to make perfume. So it's actually related to your pollination, evaporation, condensation topic. And even maybe living together. Yeah, so after that, you actually bring home your own perfume, and then we'll go back to SMU. So we start off at SMU. We are borrowing a space there. Okay, we rented a space there to conduct our experiment workshop, so we have more space, right? Okay, then after that, we go out in the afternoon, and then we come back again to SMU, right? And this part here, there are actually we're going to set up like science carnival booths. So those booths, right, like you can actually, you and your parents or you and your family, younger, older sibling can come down and actually play at the science booth, learn something along the way, and when you complete all the stations, right, you can win something. Okay, so that's what I mean by Fiesta. It is all about science. It's a whole science day that you can come for. And for that one, right, if you have a friend or a sibling or cousin to join, that's even better, because we actually have a buddy promo. So it's like, if you bring a friend, it's like almost half off, if I remember correctly. Yeah, so if that's something you're interested in, do join us. The link is in the description above me. Okay, so 2 things happening on 10 August, Chapter 2 for intensive revision, HOTS workshop primary 6, and also our Heuristic Science Fiesta that is happening on 10 August as well. Okay, great. So that's all from me. Thank you very much for joining me. So do come back next week because we have just one more theme to go, and we'll pass over the time to Mrs. Ko. She will be doing what will she doing? Oh, she'll be doing energy, the last one already. Okay, great. Thank you so much, and I'll see you when I see you. Bye. No, wait, I'll see you on 10 August, some of you.